One hell of a conference, right? I am so thrilled to be here, framed by this fantastic bisexual lighting. Feel like I'm in Atomic Blonde. I love it. Today I want to talk to you about the Container Operator's Manual. And if you want to talk back to me about it, either about the bisexual lighting and the containers, these pants, what have you, you can reach me on Twitter at Alice Goldfuss. I will be there for most of your needs. Speaking of me, who am I? Well, I'm Alice. Nice to meet you. I am a site reliability engineer at GitHub, which means I'm a professional worrier with pseudo access. This is the best photo of me ever taken, so I use it for everything now. And today I want to talk to you about car ads. Now, you know when you're watching TV, and by that I mean you know the 5 seconds you're waiting for the skip ad button to come up on YouTube, and it opens up on this beautiful, picturesque countryside in a mountain range with a serpentine road snaking in and out, and there's this sleek beast of a machine just raging through, and as it's going, there's all these stats popping up, like 0 to 60 in 5 seconds, 70 miles to the gallon, 5-star rating, and you're sitting there going, yes, science has proven it. This is the perfect car. If I buy this car, I will have achieved perfection. And if you happen to purchase that car and take it out into the field, you will realize that you are actually achieving much different things. And if you look at the bottom of the screen in really small letters, you may notice the phrase laboratory setting. Laboratory setting, because it's a car ad. And those facts and figures are basically one step away from theory. And were you to actually get that car and take it out into the field, your experience would be a bit different. And that's how I feel about most container talks. Because typically you go to a container talk and someone comes out and they say, step right up, step right up. In the next 10 minutes, I will tell you everything you need to know to revolutionize your production platform and run containers in prod. What's that? You want to run more than one container? Well, no problem. Just download this gist, don't read it, run it on your laptop, and in 5 seconds you will have a 3-node cluster perfectly tuned. And you want to run containers in prod? Well, go right ahead. After all, prod is just your laptop times 100, right? Great, thanks, and they walk off. And you're staring at this half-finished tutorial thinking, is this why sysadmins are so mean? Personally, I would like to see a lot less Docker 101s and a lot more Docker WTFs. Because there are just some things as an industry that we need to talk about concerning containers, and that's all I want to do with you today. And you might think, all right, sounds great, but why should I listen to you, Sinead DevOps? Well, I have been running containers in production at scale since January of 2015. And in 2016, I moved to a team that ran Dockerized Cassandra clusters. And now I'm on the team responsible for the Kubernetes platform underneath GitHub.com. So I've been running containers in prod for about 4.5 years, and if you consider that Docker came out about 6 years ago, that's really not bad at all. So before we begin, just to make sure we're all on the same page, I want to cover what is a container. Because have you ever been to one of those Container 101 talks? It probably went a little something like this. First, you have your host, and it's a box. And on top of that host, you have your operating system, also a box. And running on top of that operating system is a container daemon, a box. And then inside of that daemon, you have your containers, which are smaller boxes. And this is great. It's fantastic, except that it's all lies, every single piece of it. I mean, this is what containers look like to humans, but this is what containers look like to a computer. This is the top readout from a production Kubernetes host, and we see some processes running on it. So let's take a look at them. So third down, we have Docker D, which is that Docker container engine. Fifth down, we have the kubelet process, which is a Kubernetes process. And then we have some Ruby and Python processes. And those Ruby and Python processes are containerized applications. They're right there. They're not hidden in a box. They're not abstracted away. They're just running as processes because that's what containers are. Containers are processes born from tarballs, anchored to namespaces, and controlled by C groups. So talk over, you're done, just go. What does this mean? So there is nothing in tech, there is no concept of a container in the Linux kernel. There is no flag that you run when you're compiling GCC-C. That's not a thing for containers. Containers are just native Linux features stapled together. I guess this is more of like a nail gun. They're nail gunned together. And they don't actually exist in like a concrete concept. So let's dig into that a little bit. When you are writing a Docker file or some kind of container spec, you are coming up with an instruction set, a recipe for how you want that process to run, defining the directories, the dependencies. And when you build it into an image, you are creating a tarball. And when you deploy it to run, that tarball is getting unpacked and being run as a process like any other. Now here is where those native Linux features come in. The first one is namespaces. Namespaces determine what a process can see, such as other processes or directories, not everything on the host, just a slice. And to that process, that is everything. And the second feature is C groups or control groups, and those determine what a process can use. Resources like CPU cycles or memory, and together they make a container. This is a container. This is what people want you to run in prod. And if you're thinking, oh, I don't know about that. I thought it was like whales. Well, don't worry. We are going to take a nice, hard look at what it means to actually run containers in production at scale. And by the way, yes, the vast majority of my background is in bare metal deployments. I know things are a little bit different in the cloud, but just because you think it doesn't apply to you doesn't mean you can just throw it out the window. This isn't the Linux kernel mailing list. So we're going to be talking about 4 lessons. Starting off with containers have strengths. I don't want you leaving this talk going, that Lilith Fair reject doesn't like containers. I like containers. I just think you need to run them in the right way and play to their strengths. And container strengths lie in stateless applications. Now, again, what do I mean by stateless applications? A stateless application is an application that takes data in, changes it in some way, and then sends it out on its way. It doesn't keep any data for itself. It doesn't tick a counter. No state is changed. It doesn't know where that data is even going or what it's doing afterwards. It just takes it, changes it, and moves it along. And stateless applications are fantastic for scaling your infrastructure because you have all of these instance clones running side by side, and if one of them goes down, the dependencies don't care. And the other instances don't care either, provided you have enough headroom with load balancing, whatever, we're all adults. And it's in these ephemeral, disposable processes that containers shine because containers themselves are ephemeral, disposable things. And so if you have stateless applications or microservices or whatever in your infrastructure, I encourage you to consider containerizing them. And just as a note, containers are not magic boxes. My boxes are okay because we know they're lies. So, what are these strengths I'm talking about? Well, first of all, once you've gone through the rigmarole of figuring out what your process needs and you've delineated all of the directory structures and dependencies, that container is very portable. If it runs locally, it'll run on your Linux production environment. You can put it anywhere. And that also means it's extremely easy to upgrade. You just have to change a code commit or change a dependency version, build it, roll it out. And that also means it's extremely easy to iterate. And if something goes wrong, you don't have to have a huge rollback plan. You just have to deploy the previous image version. Much shorter run book. Excellent. Now, you can get all of this from a blog post. You can get this from one of those Docker 101 talks. Let's talk about something a little more crunchy, like disaster recovery. Who here has had to deal with disaster recovery? Yes, we are all recovering from our own personal disasters as we speak. Typically, when you start hearing the words like FedRAMP, like, yeah, that's when you have to care about disaster recovery. Who here has had a disaster recovery exercise that looked a little something like this? Where you're sitting down to figure out how to deploy all the applications, and if you find out that this one deploys with Jenkins, this one deploys with Capistrano, and this one deploys with a cron job running off someone's laptop every day at 3 a.m., and were they to quit, you'd be in big trouble, hypothetically. And then like the day of the exercise, you're there deploying something, and it turns out the dev who wrote down the instructions missed something, so I need to go find them or someone else from their team, and it's taken forever, and the auditor's like, tick, tick, and they're like, yeah. Meanwhile, if things are containerized, they are all being deployed to the same place in the same way. And having been on the Capistrano and container side of a disaster recovery exercise, I much prefer it over here. It's so much faster. And it's also faster for on-call. Has this happened to you? You get paged, you wake up, and you go, that is not mine. And now you have to figure out who it belongs to and page them and wake them up, and it takes even longer. Well, if both your services are containerized and you get paged by mistake, you can at least try deploying their service for them. Sometimes that's all that's needed. And if that fixes it, guess what? You just solved an incident in less time with less people, and now they owe you one. And I have also done this, and it's great. Containers are also good for testing environments. Because what is a testing environment if not some place where disposable, ephemeral things happen and then clean up afterwards? No artifacts. For some of you who may be writing desktop applications where your production environment is someone else's computer, this is where containers can really help you, because you can run different versions of your desktop application in a testing containerized environment. You can say, ship logs, your test results to some centralized database, and then everything will get cleaned up at the end of the day. You don't have to soil your personal laptop trying to repro customer issues. All I'm saying is you have some place in your architecture that has disposable, ephemeral things. Containers can really help you out. So if containers have strengths, it makes sense they would also have weaknesses. And if containers' strengths lie in disposable, ephemeral, stateless applications, it makes sense that their weaknesses would be in things that hold their shape, stay around, molded, like stateful apps. And whenever people talk about stateless applications and containers, they always want to talk about databases. They're like, yeah, I read a Container 101 post, and now I'm just going to throw my databases into a container. It'll be great. Okay. And whenever they say that to me, I like to say, are you Google? Now, that tends to hurt some feelings, because what they're hearing is, are you a success? Are you a household name? Have you had a lot of lawsuits lately? But what I'm actually saying is, are you routing billions of requests to thousands of databases across dozens of data centers per second? Usually, the answer is no. I know for some people here it might be yes, but usually it's no. And in which case, you really don't have to containerize your databases. Now, I understand why you would, especially if you're on bare metal hardware, because you get faster provisioning, you get better stability, it's easier to fail over and recover. You've got dev teams working on features, and they want a database now, and you have to put in your hardware order and wait 3 months for Dell to even wake up and get it to you. I get it. I understand why you would just want to spin up a containerized database. But have you considered that you can get all of these things with some tooling and the cloud? And when I say that, people go, do you have any idea how much money that would cost? Apparently, it would cost more than hiring your own database container platform team, having them research and build it out for you, and make sure they know how to contain and secure all that data. Sure. Because you're going to be dealing with a lot of data. And do you really want to be putting money and resources into building and maintaining a platform that isn't even the main part of your business? But some people do. And when they do this, they go about it in usually two main ways. So let's talk about that. The first way they do is that they have containerized database instances that store their data somewhere else in some sort of network-backed storage like Ceph. And so if one instance goes down, everyone's fine. And that instance comes back up and gets its state and starts sending data again. But the problem is, the more data you get, you will eventually become network-bound. And if you're just dealing with lightweight databases that wouldn't be network-bound, I don't really see the point of having containers. Okay. The other way people do it is they're running containerized database instances that store their data locally on the host where the instance is running. And now if you lose an instance, the data stays behind. So like, what do? Well, you can just regenerate that instance in place. And if you recall when I said I worked on Dockerized Cassandra clusters, this is what we did. It looked like a Cassandra cluster like any other, except the JVM was containerized. And yes, did containerizing the JVM make it easier to upgrade? Sure. Did it make it easier to iterate? Yes. Did we have to write a lot of custom tooling? Yes. Does it sound good on a resume? Yes. Was it worth it? Probably not. Another way people do it is, okay, that instance goes away, data is behind, generate the instance somewhere else, but now you still have to move that data, and again, you run the risk of becoming network bound. And if you're getting to the point where you're laying down dedicated fiber for your homegrown database container platform, maybe you should have gone to the cloud. But I get it. You want to containerize your databases? Okay. My only recommendation would be to keep it small. If you want to containerize a test database while the hardware is coming, that sounds great, makes total sense, allows people to work faster. If you have, say, an assets database where if it goes down, the website just looks kind of ugly, fine. But don't put your 16 terabyte customer account database in a container, you will be sad. And again, may I recommend the cloud? Because all of those providers have automatic failovers, scalable databases, read replicas in multiple regions. You get a lot of bang for your buck. And you might as well be taking advantage of vendors whose sole job is to provide this service. That leads us to lesson number 3, which is containers need friends. Now, typically, people say, oh, we're gonna do containers now. We're just gonna, roll out containers, no harm, no foul there, except it's never just containers. Containers are not one thing. Containers are a vast ecosystem of different software solutions that you need to research and stick together to create a platform. And there's different things you need to consider and research to get to that. For example, your dev setups. How are you going to be generating those tarballs? Are you going to be using Docker? I mean, it's basically tailor-made for local setups, but you don't have to run your containers in prod with Docker. You should look into that. Orchestration. How are you going to make sure that an application that needs X amount of CPU cycles and X amount of RAM runs on a node where that is available? What piece of software is going to determine that? Management. Are you going to have clusters? If so, how are you going to handle things like DNS or failovers or access control? Or are you going to have clusters that only run one kind of app or a cluster that's PCI compliant for security reasons? And networking. You're going to be adding new layers of extraction on this platform. How are you going to handle routing now? How are you going to handle access control? Can everything just talk to everything else? Can any person access any host? And how about service discovery? How is service A on cluster 1 going to access service B on cluster 35? You need to take a look at that. And just to give you an idea of what you're dealing with, here is an example of projects that handle networking in Kubernetes. And they don't all do the same thing. But sure, you did your research. Congratulations, you now have containers. You did it. Now you have to integrate that with your already existing platform. For example, deployment. How are you going to deploy to your new platform? Are you going to use the same tooling as what you currently are using? Or do you have to build something new? How are you going to maintain 2 parallel deployment systems? If one breaks, what takes precedence? What gets fixed first? Monitoring. Are there new data endpoints, new metrics that you need to consider to determine if a container or pod or cluster is healthy? Does your current tooling support this? Do you need to build new tooling? Do you need to buy new tooling? Do you need to train people on the new tooling? Provisioning. How are you going to provision your container hosts, your cluster hosts? Do you need to make any changes to your base images? How are you going to determine what takes precedence when it comes to ordering or your cloud budget, the current existing legacy stuff, or your new container platform? And last but certainly not least, debugging. Now that you have a brand new platform with new layers of abstraction, how are you going to make sure that you understand it and can debug it when something's broken? And not just you, the infra people, but people running their services on your platform. How are you going to make sure that they can self-serve to troubleshoot their apps? And because you are going to be considering all of these things and doing a lot of research, you will be looking at a gradual rollout. And in my experience, on bare metal installations at medium to large size companies, you're looking at least a year. And when I say at least a year, I mean in a year, you will have kind of a platform and maybe one service running on it that no one really cares about. And you're going to need a year to get there, and it's going to be a lot of trial and experimentation. And at the end of the day, not everything is going to be containerized usually. Usually you're looking at a hybrid solution where some of your architecture is containerized and some of it isn't, like your databases, right? And you need to know what your actual goalpost is so you can set expectations accordingly. This brings me to my last lesson, and you can ignore everything else I've said. You can be like, whatever, I'm going to run containers on my phone, Kubernetes App Store download, whatever, I don't care. You cannot ignore this last lesson, which is containers need headcount. Usually, when people want to roll out containers, this conversation happens behind closed doors between two people wearing suits. And the first person says, we need containers. And the second person says, let's give it to ops. After all, ops already owns inventory and provisioning, configuration management, networking, deployment tooling, monitoring, incident response, maybe security, maybe your databases. Let's put containers on top of that. I mean, containers are just like a new Jenkins, right? No, they're not a new Jenkins. Rolling out a new container platform is like building a brand new data center in a city no one's ever been to, with hardware no one's ever heard of, and software no one's ever touched. It is not a new Jenkins. It is a completely new thing, which means you need a completely new team, and you need to hire for that team. And there are a certain amount of skills that you need to consider when hiring for this team. For example, you need someone who understands operations, and preferably, you need someone who understands operations at your company. And yes, this means you can take someone from your ops team and put them on your container team, but you are going to backfill them on the ops team. You can't get that past me. You keep clapping. Do you want lunch or not? You want someone who understands operations at your company because you want to know where the skeletons are hiding and the snowflakes are running, because eventually, hopefully, you want to migrate them to your container platform, so you want to know what's coming down the pike. You want someone who understands deployments, both at your company and in the container ecosystem at large, and who has opinions about what you should be rolling out there and what would constitute a successful deployment and a good experience. You want someone who can write tooling, because even after you research and decide all your different container components, they are not going to fit together correctly. And they are not going to fit together with your systems correctly, which means you will need someone who can stitch them together. Monitoring. You will need someone who understands what a healthy container platform looks like, SLAs, SLOs, how to integrate those things, is really good with dashboards in a pinch. Someone who understands the kernel, because you're going to get some real weird interactions between the kernel and your container platform. You can count on it. So someone who can analyze a kernel crash, someone who can run benchmarks, someone who can go sifting through the Cs. You need someone who understands those lower levels. Someone or someones who understands networking, because rolling out networking in a container platform is an adventure. There's multiple different schools of thought on how to do it. You need someone who can navigate those waters. Security. You need someone who understands security and how it applies to containers. Containers have a bad rap when it comes to security, but they have come a long way. And you need someone who knows what they bring to the table, where the gaps are, and what is important to you. And that person, incidentally, needs to be in the room when you are rolling out a container platform, when you are talking about it, not at the end when you're seeking a check mark because an auditor told you you needed one. Security needs to be a first-class citizen on your platform. You need someone who can aid in internal adoption. You need someone who can walk up to a dev team and go, oh, that's a really nice roadmap. Oh no, it fell. Guess what you should be doing? Why don't you deploy your service to our janky-ass platform, watch it break repeatedly, and then tell us what we did wrong? Peaches, thanks. You need that person. Because if you don't have anyone migrating to your platform, you don't have a platform. And last but certainly not least, you need a project manager or a product manager, because internal product managers are a very important thing too. You need someone who can keep morale up, who can make a roadmap for you, who can have those hard conversations with leadership when you research something and it turns out that Istio, and you need to do something else. You need someone who can have those hard conversations, who knows that it's a year-long process at least and can keep the band together. Now, not all of these skills need to be an individual person, but they also can't just be one person. You are hiring a team. And I would say ideally it should be between 6 to 8 people. But at the very least, it should be 4 people. Because eventually this team is going to be on call for the container platform they just rolled out. And an on-call rotation of less than 4 people is untenable. You need at least 4 people. And once you've gathered them and hired them, you need to empower them to succeed. You need to write the checks for them to explore in a cloud environment while they figure out what the platform's going to look like. You need to be okay with failure, and you need to be okay with rearranging other people's roadmaps for that migration to happen. You need to set them up for success. You can't just put them in a closet and then later be like, where's my containers? You can't do it. You have to be working with them. So today, we took a nice look at what it means to run containers in prod. We talked about their strengths, which lies in disposable, ephemeral, stateless applications. We talked about their weaknesses, which is in stateful applications like databases and how you should probably just go to the cloud. We talked about how deploying containers is a vast ecosystem of choices and it's never just containers. And we talked about how you need to hire a complete team to run containers for you. But that doesn't really answer the question, should we use containers in prod? Well, I don't know. There are some indicators. For example, do you have stateless services? Do you have a large heterogeneous platform that you want to bring more in line? Do you have the time, the money, the people, the org support to pull this off? Then sure. Try containers. Why not? On the other hand, if you have a monolith and few support services, if your databases have pet names, if you have a small team with no org support, if people are just like, well, it's you and it's her, and you both already work here, so congratulations. Or if you just want to do it to spite me, then maybe don't do containers. Unless it's to spite me. Please roll out a container platform to spite me. Oh, I need some entertainment. At the end of the day, a really good litmus test for whether or not containers are right for you is to ask yourself, do you want containers or a blog post? If you are listing all the reasons that you need a container platform, and reason number 2 is, it would be rad. Don't do it. It's not worth it. There are way better legacy solutions out there with greater rates of adoption and greater communities for support than containers. You really don't need to do it because, spoiler alert, it's okay not to use containers. It really is. They're just one tool in the toolbox, and if they're not actually solving the problem you have, don't do it, because that container platform is going to be around a lot longer than your Hacker News ranking. But if you do decide to roll out containers, just know that they can be a little tricky, but if you have a good team by your side, you will get it in no time. Thank you very much.